Hello everybody, this is me Vinu Venkatesh on behalf of Sai Education for Comparative Examinations. So we're doing mensuration and we had started rectangles last time. Let's continue that. I just want to take you back to question number 5. There's a mistake in this question. This should be cost per meter is 50 rupees. Okay. So you should read the question as the cost of fencing a rectangular field is 25,000 rupees. Cost per meter, not square meter, is rupees 50. Length is 1.5 times of width. Then what is length? So here it should be P and not A. So P stands for perimeter, should be 25,000 divided by the cost per meter. So you will get the number of meters that are fenced. Fenced means putting a fence. So how do I know whether this is a perimeter or area? Because in a rectangular field, normally we put the fence on the edge. We will never put the fence in all of this field. We will only put it on the edge, on the boundary. So that's why we can assume safely that they're talking about perimeter. You will never put fence inside a field, right? You will only put it on the boundary. So that is a difference. So that's how we know that we're talking about perimeter. So this is the perimeter of the rectangular field, 500, not area. This should be P. And we know the formula for perimeter is 2L plus B, 2 bracket 500. So L plus B is 250. Okay, and they're saying width is, let width be X and length be 1.5X. So 1.5X plus X is equal to 250. So therefore 2.5X is equal to 250. When you solve for X, you will get X as 100 and length will be 1.5 times X. X is width. So length will be 150 meters and width will be 100 meters. Okay, we did number 6. Let's do number 7. Find the number of square tiles if the length and width of a room are 11.25 meters and 6.75 meters respectively. So here first you have to find the area. Okay, convert it into centimeters just for ease. We know that 1 meter is equal to 100 centimeters. So 11.25 meters is equal to 1,125 centimeters into 675 centimeters. This is in meters, converted into centimeters, divided by the highest common factor of 1125 and 675, which is 225. Divide this area by twice by square of this. You will get the number of tiles. We have learned how to calculate the highest common factor, so please do it accordingly. Okay. So number 8 and 9 are very similar to number, which was that in the square section? I think it was number 11, 12. Yeah. So it's very similar to number 11 from the square section. So 8 and 9 I'm not doing. Please do it yourself. Next, how many small balls can be placed in a box of these dimensions? See, when you're given length, breadth and height, we are not talking of a rectangle, we are talking of a cuboid. What is a cuboid? This is a cuboid. Remember we talked about a room. A rectangular room is also called a cuboid. It has a length, it has a width, it has a height. This is called a cuboid. And so it's in a rectangular box and the radius of the balls are 1.5 centimeters. Alright. So how do you find it? We are talking about volume now. Volume of this room is length into breadth or width into height divided by the diameter of the balls. So it will be 20 into 14 into 7 divided by diameter. We know that 2 times the radius is equal to diameter. So 20 into 14 into 7 divided by 3 will give us 48 balls. So this is the same, 20 by 3 into 14 by 3 into 7 by 3. Same thing. Okay. Number 11. The cost of painting 4 walls of a room is 250 rupees. Then what will be the cost of painting 3 times the larger room? It will be nothing but 3 square 9 into 250, which is 2,250. Okay. Now the capacity to keep rice in a room is 345 tons. Then what will be the capacity to keep rice in a room which is thrice greater? Now we know that in a cuboid you have length, breadth and height in a room. Okay, so it will be 3 times the length, 3 times the breadth, 3 times the height, which will be the volume of a cuboid. The volume of a cuboid is, say for example, the volume or the capacity, how much we can store in this room is LBH, volume. Okay, so if the room is 3 times larger, then the volume will be 3L into 3B into 3H. So the volume will increase. So it will be 3 into 3 into 3, which is 27 into the original volume, and that will give us an answer of 9,315 tons. Okay, because length is increasing by 3, breadth is increasing by 3 and height is increasing by 3. Now find the length of the longest pole that can be placed in a room 12 meters long, 8 meters broad and 9 meters height. For a cuboid, the diagonal square, the diagonal is equal to square root of length square plus breadth square plus height square. In a rectangle, the diagonal is square root of length square plus breadth square. So here we are talking about a room where you are giving length, breadth and height. Find the length of the longest pole. The longest pole will always be the diagonal. The diagonal is nothing but this. Say I'm just drawing one line here. This, okay? That is the longest pole or the longest line or the longest distance in a rectangular room or cuboid. So it will be the square root of length square plus breadth square, which is 8 square, plus height square. That will give us 17 meters. Okay. Number 14. How many bricks, which are 25 centimeters into 11.25 centimeters into 6 centimeters. These are the length, breadth and height of the brick. Remember, brick is a cuboid. Is required to build a wall of 8 meters, 6 meters and 22.5 centimeters. First of all, see that the units are all the same. They should be the same. You have to convert it. Okay. So what we have to do is, it should be the volume of the wall divided by the volume of the bricks. That's what they have done. That will give you the number of bricks. Because think of it this way. See, let this be the wall. Okay. Okay, this is a small wall like that. Alright, so this is a cuboid, right? Now we have to use bricks such that we build this wall completely, like we fill the wall, we build this wall. So how many bricks will be required to build a wall of this capacity, given that the bricks also have a certain capacity? The bricks are also cuboids. Okay, like this. You have seen a brick, you have seen a wall. So how do we solve this? We find the volume of the wall divided by the volume of one brick. That will give you the total number of bricks. Make sure that the units are the same, and once you do it, you'll see that you need 6,400 bricks. Okay. Now number 15 is a direct application of the formula. You can do it by yourself. One side of a rectangular field, this is not a cuboid, it's a rectangular field, is 15 meters and one of its diagonals is 17 meters. Find the area of the field. Very simple. We know the relation between area and the diagonal and the rectangle and the length. We know how to find the diagonal given the length and the breadth. And then once you find the breadth, find the area of the rectangular field. We'll continue in the next section. We'll stop for today. So as I always say, please keep practicing and all the best.